After this discussion about the term logistics and your exercise, let's go and have a look at the term management. Maybe you discussed this concept in other first semester courses already, though I don't want to give you an extensive discussion, an extensive definition of what management means, but I want to give you a rough outline of some of the main management activities, some of the main activities that every manager, every management organization has to support and has to do. The first activity is planning and decision making. The second activity is organizing, and the third activity is control. So for planning, it means we have to think about the possible outcomes of a decision, identifying the alternatives, evaluating the alternatives, what are the goals that we want to achieve by this decision. And of course, in logistics management, we do this in the context of a logistics system. The second decision is organizing. You can have a look at the organizational chart of a company to get an idea how the company is structured, which departments are there, who is the CEO, which supporting roles does the CEO have, who is doing the auditing, sometimes, it's always the distribution of work on the department level, but also on the individual person's level, who is responsible to get which job done. These are organizing issues. How do we distribute the information within the company? These are all aspects of organization. You can try to search the Geotech website to find the org chart of Geotech, and this will help you understand the university in a better way. This is part of an organization issue. And the third and final step that I outline in this rough definition of management is control. We measure the performance of a system, here of a logistics system, and we try to monitor what's happening, and if we don't like what's happening, we need to come up with measures, with initiative to change how the system works, to make it better. And this is often also aligned with planning decisions, how to make better planning decisions. We will address all these three main aspects of management in this course. However, our focus is clearly on the planning task. The focus is clearly on the planning task. How to make plans to design better logistics systems, how to make better decisions in logistics. So expect that the focus of this course is on the planning. And for the planning, we will use in this course, but although in most of the courses in the whole logistics program at Geotech, we will use quantitative methods. Basically methods based on mathematics and statistics. And this is why you need to be good in these courses, in Math 1 and 2 and statistics, because you need these skills in all the future courses in this program. You saw already some of the math skills that you need for logistics management. On the one hand, in my opinion at least, the required math skills were not very high for this course regarding of the calculation problems, but maybe in terms of the mathematical concepts that we use and how to apply these mathematical methods outside a pure math context, but in a logistics context. Yeah. If you recall, for example, the break-even analysis, this was just the calculation of the intersection of two straight lines. The straight lines represented cost or revenues, and this was just an application of a mathematical method to a business context. In general, most of the modeling, most of the way we use quantitative methods for planning follows these 4 steps that you see on the slides. Most importantly, we start with a real-world problem. We want to solve a real-world problem. We are not happy with how something is running in the real world, and now we want to change this. In management, in everyday decisions, in your decisions every day, often the straightforward solution, the straightforward way to solving a real-world problem is by using intuition and experience. If you have solved the problem many times before, you already know a lot about this problem, and maybe you find it even very easy to solve this problem. So you go directly from the real-world problem that you recognize to the solution of the real-world problem. Sometimes in everyday decisions, this is a very good approach. It does not require a lot of time, and the solutions are often acceptable. However, the more complicated the real-world problem becomes and the less experience we have with this real-world problem, the more effort we should put into solving this real-world problem. And when we use quantitative methods, what we do, we try to come up with a mathematical representation of the real-world problem. This is usually a way simpler way of dealing with the real-world problems. We make some simplifications. We try to focus on the most important characteristics of the real-world problem and formulate a mathematical problem. Then we apply algorithms, solution approaches to solve a mathematical model. A very popular way in the context of logistics are algorithms from operations research, which you will take next semester. But of course, there are other solution approaches. When I talked about the break-even analysis, which is just the intersection of two straight lines, then you need to apply straightforward calculus to calculate the point where the straight lines are intersecting. And then, by applying these algorithms, you get a solution to the mathematical model. You do not get a solution for the real-world problem, but only for the mathematical problem. What you do, now you take this, let's say, theoretical or model-based solution and move it into the real world. And you ask yourself, is this solution for that model that I constructed, is it an appropriate solution for the real world problem? Is this solution found by the model, by using the model, good enough? If your answer is yes, then you're done. That's it, perfect. If you think, no, this solution is not good enough, I need to improve this solution, then maybe you need to repeat these 4 steps again. Maybe you need to look at maybe you need to look at the real world problem from other point of views. Maybe you need to emphasize stronger on other characteristics. You need to change your mathematical model. Maybe you need to extend this model. You solve it again and check the new solution. Is this solution for the mathematical model good enough for the real world problem? Yes, then you're done. No, then you have to repeat it. In higher education, we often focus on steps 2 and 3. Yeah? You are presented by some mathematical model, or you create some mathematical model, and you have to calculate a solution to this model. This often can give you the wrong impression that this is very important. Then students, steps 2 and 3 are important, but if you look at it isolated, you somewhat lose the contact to the real world. So this is something that you need to do for yourself. Always make the connection to the real world and always have these 4 steps in mind. Yeah? Once you do 2 and 3, you have to move the solution into the real world, challenge the solution, is our approach good enough or not, and repeat these steps again. Yeah? And one more thing that you should take away from this graphic and from general all the content we discuss in this course, there are typically 3 levels that you need to distinguish. We have the problem level. The problem is from the real world. This is the issue that we want to solve, that we want to improve. We built a model for this real world problem. And what you need to keep in mind, we can build several different models, very different models for the same real world problem. And then depending on the characteristics of the model, we have to choose a solution method to solve this model. So always keep these 3 levels in mind: problem, model, algorithm. Yeah? Don't confuse these 3 levels.